Okay, this problem is 16.3, number 1. This section is all about the fundamental theorem of line integrals, which basically says that if you're integrating a gradient, dr, then you can basically reform the f that the gradient came from, and then you can evaluate the integral at the endpoints and not worry at all about the path. Of course, it has to be possible for you to turn that gradient into its original function. If you do, then that original function is known as conservative. If you can't, then this method simply won't work. So let's check this to see whether or not f is conservative. In order to do that, it's pretty easy. If this is the gradient of some other function, then certain properties will hold true. One of those is that its second partials will be equal. So this is the first partial, that's fx. So I'm going to check fxy by taking the partial of this with respect to y. That's 0, this is going to be 2y. And then this guy right here, that is the first partial with respect to y. So I'm going to take the second partial, the mixed partial of fyx. This guy fyx, again, this is 0, this is 2x. And unfortunately, the mixed partials are not equal. And what that tells me is this was not the gradient of some original function. That is, the original function doesn't produce this as its gradient. Therefore, that original function is non-conservative, and therefore f does not exist.